Okay, so what we're going to do, I've written everything out on paper, so let me go to my webcam and show you. So we have the null hypothesis. We are given a standard deviation. In order to run the tests in StatCrunch, you need to convert everything to variance. So the standard deviation that we are given as our claim value, we have 0.005. Variance, we would need to square that. Likewise, when we have the test statistic or the sample standard deviation 0.0034, we need to square that in order to have the sample variance instead. So StatCrunch is going to be asking us for these values. Actually, I think all it asks us for is the sample variance. It doesn't actually ask us for these values up here, these hypothesis values. Now, what we'll do here, I've drawn out two distributions, two chi-square distributions, one of them showing the critical value method. So what we have here, since we have a left-tailed test, essentially we've got a less than here in our alternative hypothesis. So we have a left-tailed test. What that means is that 0.05, the alpha value, is the area in the left tail. So when you look, let me go ahead and switch to my screen here. When you look at the table, the area to the right of the critical value is then 0.95. You can see, switching back to my webcam real quick here. Let's see here. Switching back to the webcam, you can see the area to the right is 0.95, the area to the left is 0.05. The 0.95 is what we're looking up in the table in order to come up with our critical value. So we have 0.95 is the area to the right of the critical value. 22 is our degrees of freedom because our sample size is 23. So our critical value, if we go back to the webcam here, you can see our critical value, 12.338. So that would be what we compare the test statistic to. Now over here, I'm setting up for the p-value method. The rejection region is over here to the left of the vertical line on the graph, and what we see is over here in this first graph, any value, any test statistic value that's less than, so reject, if chi-squared naught, so the test statistic value is less than 12.338. And here we reject if P is, let's see, if P is less than 0.05. So what this indicates here, on the chi-square scale, what you notice here is if the test statistic is less than the critical value, we're in the rejection region. Here, the p-value is the tail area. So if the p-value is small, in other words, less than alpha, that means we have a smaller tail. And that means that our critical value is further to the left, thus cutting off a smaller tail. So a p-value that is less than alpha means a test statistic that is further into the tail, in other words, into the rejection region. If we have a p-value that's larger than alpha, that would imply a larger tail area. In other words, the p-value has to be over here to the right, which is outside of the rejection region. It's in the status quo region here. So what we're going to do is go to, let's see, let me switch back to my screen here. We're going to go to StatCrunch, and we'll go to Stat, Variance Stats, one sample with summary. Now the sample variance, I'm just going to put 0.0034, and I'm going to, use a caret and square that right there. Sample size is 23. Notice that sample size, not degrees of freedom. The hypothesis test, my test value is 0.005 squared. So I'm just going to square that right in the text box there. And then I'm going to also include a p-value plot. So let's compute that. And let's see what we get here. So what we get is chi-square test statistic 10.1728. So you notice that our chi-square test statistic, so chi-square naught equals 10 point, what did we say that was? 10.1728. 10.1728. That would be right around there, not to scale, but you get the point, 10.1728. That's in the rejection region. Likewise, what we find out is that the p-value 0.03, so I'm going to write that down real quick, p equals 0.0307. Go back to my webcam. So the p-value 0.0307 is in fact less than alpha. It's less than the 0.05. What that means is that here's our p-value. The area in the tail is smaller than alpha, which means that our test statistic must be in the rejection region in order to cut off a smaller tail area. Okay, so I think that's about it. Let me know if you have any further questions. I hope that helped a little bit. I think we covered just about everything as far as using StatCrunch and the interpretation.